All right, so I have no idea. I saw it too. I don't know. So we did this example yesterday. All right, the scenario is we've got two populations. We got the people that have debt in New York, credit card debt in New York. People have credit card debt in Texas. Those are two complete populations. We take 250 out of New York. We take 250 out of Texas. They are completely independent, meaning that a person that's in New York is not getting chosen as a person in the sample of Texas, and vice versa. The populations they came from are normal, and they were chosen randomly. Okay, so 250, they were chosen randomly. Those are the conditions needed to be able to use a z-test on the difference of means. Okay, now yesterday we talked about the null and alternative hypotheses being these. Okay, so in a difference between means, we're always going to assume, like we have in the past, equality in the null hypothesis. Now yesterday we talked about this, if that is not equal to, okay, or sorry, that is equal to, this one we said was not equal to because it just said, is there a difference? They can say that, we think, in 1980, the mean credit card debt was less than it is in 2020, okay? So if that would be the case, we could make this less than or equal to and keep this then equal to. Does that kind of make sense? So that can't happen with your alternative hypotheses like it has with all other tests, okay? But we're looking for the phrase, like, difference between means. So we went through yesterday. Now, we already have the process data, which is exhibited here in the table, okay? Now, remember, this is standard deviation. We need the variance in the formula, so all we have to do is take our standard deviation and square it. Or if you process your data, you can just find the variance and plug that in here as well, okay? And then not square that. So just know which value you're using, standard deviation or variance, inside here. The expected difference between the two populations, okay, comes from the null hypothesis, which we said we always assume that there is no difference. And then we'll let the data tell a story of whether there is difference or not, okay? So we assume this first. That's the expected difference, which means that they're the same, so the difference is 0. So when we standardize our data, this quantity right here and the difference of means is always going to be 0, okay? Then we just plug in the other information into this formula, and we typed this in yesterday. We got negative 1.11, okay? So we got negative 1.11. We found that on our normal distribution in comparison to our critical values based off alpha 5%. That's where the negative 1.96 and positive 1.96 came from. The negative 1.11 says you fail to reject, okay? So we failed to reject there, which means, okay, because of what the claim was, if we fail to reject the null hypothesis, that means this blue thing is, one, it was accepted to be true at the beginning, and now we don't have evidence to say anything to the contrary, so it's going to stay as the true thing. Does that make sense? Okay, we failed to reject that. So that means we do not have any evidence or enough evidence to support that. So in phrasing our conclusion, we would say we failed to reject the null hypothesis. There is not sufficient evidence to support the claim that there is a difference in the means between credit card debt in Texas and credit card debt in New York. That kind of make sense? Okay. Always going off the fact that this, before we do any testing, we're saying that that thing's true. Okay. And then the test tells us whether we could accept that or refute that. Okay. Questions on that? Okay. Now we also can do p-values. Okay. So a p-value would still be determined off of that. Okay? So we would take Excel. We would take Excel and we go equals norm dot dist. Okay? I want the x value, that's negative 1.11. Standard deviation, mean 0, standard deviation 1. We'll hit true. Okay, and that will give me, that's the left tail. Now this is, so that would be telling me what this area right here in red would be on my curve. Okay? We want the area that is red here along with the area that is red over here. That would be the probability value, the p value. So we're going to equals 2 times A1, and that becomes my p value. Okay, remember, in two-tailed test, you have to double that value. Okay, and we compare that then to the 5%, and our p-value is greater than our alpha. And when your p-value is greater than your alpha, you fail to reject. That's the conclusion we make. Okay, does that make sense? Now, in doing this problem yesterday, there was quite a bit of calculations we had to do. Okay, it's kind of messy. A lot of the calculations were already done for us and presented in this table. Okay, what I want to show you today, you're going to see this in your homework, so I want to make sure that you have the ability to do this efficiently. I'm going to give you a problem that looks, and actually let's just go ahead and do this. Everybody get your computers out. You already did? All right, go to Schoology. Go to Schoology. Okay. So when you get to school or Schoology and you go to statistics, okay, I want you to click on this 861 document. Open that up. Now, in order to cut and paste the things out of this, you need to actually download that. So just download it, put it on your desktop, and then when we're done with it, you can delete it if you want to. What? So some of you got it? Okay. All right, so open that up, and then just go ahead and minimize it. Then you need to open Excel up, okay? Because right now, Excel, with that data, isn't going to do anything for us, okay? It's not going to be able to do this hypothesis testing for us. Excel, and this is a lot of programs like Excel, are built this way, where you have to, in order for Excel, you ever sit and open a program and it just loads and loads and loads? Because there's a lot, it's got a lot of stuff to start processing. So Excel is that way. If you loaded the full Excel and everything that it does, all the commands and functions that it does, in its entirety, it would take forever to load it. So what they do is they package them into like little toolkits, and you basically have to tell Excel to open with one of those toolkits, okay? I want to show you how to do that with what we call the data analysis toolkit. So once you open Excel, you're going to go to File, okay? Now, I'm not sure, because, Chandler, you have a Mac, right? I'm not sure if this is going to work for you, because it wasn't working for somebody. Somebody this morning had a MacBook, and it wasn't. So I had to do some research on how to do that with the MacBook. But you're going to go down to Options. Do you have an option there when you go to File? No? Okay, so that's the problem. I don't know where that's at on a Mac. If I go to Options, okay, it's going to bring this up. All right. You need to go down to Add-ins. Okay. You need to go to Add-ins. Okay. Now these, you see in mine might be a little bit different. You probably don't have like tools or how you say it for Excel. There's different commands that are built outside of Excel that you can merge into Excel that can do things for you efficiently. Okay, different formulas and stuff like that. I want you guys to go down here to where it says Manage, and it says Excel Add-ins. Just click OK, and this will pop up. Okay. Now yours is probably only, it's got these 4 boxes, and you probably don't have anything check marked. Okay. Check mark the one that says Analysis Tool Pack. Should be, I don't know. Sorry. All right. All right. Then hit OK. All right. Once you've done that, you've told Excel in this data tab here to load our data analysis tab there. Does that make sense? Okay. Before you did that, we should have looked at this before you did that, but before you did all that, this would not have been there. Okay. Is everybody okay with that? All right. So that should, now that we've done that, that should open up every single time that you close down Excel, open it back up. That will be there until you go back through that process again and uncheck box or check mark that box. All right. Now go to that document that I sent you, that you downloaded. Okay. Just want to read the scenario here. It says a production engineer claims that there is no difference in the mean washer diameter manufactured by 2 different methods. So we're talking about washers here for like nuts and bolts. Is everybody on the same page with that? Okay. First thing I want to do here is just let's write our hypotheses. Okay. If we've got H sub 0, H sub A, okay, says a production engineer claims that there is no difference in the mean. What's another way of saying no difference between 2 things? That they are the same, they're equal. We're saying here that population 1 is the same as population 2. That's their claim. Does that kind of make sense? Okay. Then the alternative hypothesis would be what? Our alternative hypothesis would be that, right? Now, instead of us going through and actually finding that z-score, because look at our raw data over here in the left-hand column, okay? That's all the washer diameters from 2 methods, okay? Method 1 being this column here, and method 2 being that column, okay? If we wanted to go through our formula, we would have to find the mean of these, both. We would have to find the variance of both. And by hand, that's a very tedious and time-consuming process. You would probably, if you were going to do it by hand, you would probably still use Excel to find the variance. But if we're going to do that, we might as well use Excel to do everything for us. Okay? So, open Excel up. Okay? And you're going to come over to your Word document, and you should be able to select that entire first column. Okay. Well, you can put both columns in at once. So if you select both columns like this, that's fine. You're going to copy those, and then you're going to go over to Excel and paste those in. Okay. So it should paste those in so you don't have to type all that stuff in. When you get to Math Excel, there's going to be a couple questions in your homework that does this. There should be a box on like the window that you can blow up to see the data. There should be a box that allows you to copy it, puts it on your clipboard, and then you can merge it over here, okay? The only thing, if you're going to use this in Excel, when you merge it over, they have to be your data has to be in columns. So you might have to do what I did at the beginning of the class and kind of cut these because they were in like a box like that. You might have to cut them out and structure them so that they're in a column. Does that make sense? Okay. Also, the tool pack is going to not be able to calculate the critical values. All right. So what we need here, and I'm going to type this in as I'm just going to say variance of method 1 and then variance of method 2. But I need to know what the variance is of this first method, which is this first column. So I'm just going to hit equals var dot s, okay, and then you want to highlight this first column. Okay, so I'm just going to go A to A. Hit enter. Yes? Sorry. Okay, so I'd be looking at that var.s. And it's .s because it's a sample, right? Okay. And I'm going to go B to B. That's just going to put the whole column there. And if there's a vacant cell in the column, it will interpret it as not existing. Okay. So then I hit enter. Now, did anybody get values that were different than that? Okay, because some of you might have gotten, because you just kind of watch what happens with Excel. You can adjust your width of your columns. If I adjust my width, see how it changes the rounding? Okay. So what I like to do is, I'll highlight all of these, and I'll double, you see where I put my cursor goes from that down arrow when it's in this column to that symbol, or that cursor, to that one. So at that tells me I'm on one of those grid lines between the two columns. If I double click on that when they're highlighted, it will auto fit to the character spacing of the cells. Does that kind of make sense? The reason I'd like to do that is because of the way that we have to type in these variances here in a moment. All right. So now we've got all the things that we need. Okay, and we haven't physically calculated anything yet, right? We just cut and pasted a bunch of stuff and used those two formulas for variance, which we've done quite a bit so far this year. Now you're going to go to your data tab. You're going to go over here to data analysis. Click on data analysis, and this should show up. Okay, so we've talked about in the past, and we've built some things in the past that allowed us to just type in our data, and with the formulas already built in, it would spit back to us information. Maybe it spits back to us a confidence interval. Maybe it spits back to us a p-value or something like that. And we could build those. Excel or Microsoft has already built some of those for us. Okay, and these are a list of ones that are already built. You could probably do a Google search for Excel add-ins. Say, I want an Excel add-in for whatever type of hypothesis testing, and you maybe can find one that you can add in. We will eventually do this first one here called Anova single factor. That's a pain in the butt by hand. It's like 9 formulas to get we call it an F test. But it's very, very complex. But with Excel, all you got to do is basically put your data in and select it correctly. And it will do everything for us. Okay, and we'll use that quite a bit in chapter 13. If we scroll all the way down, we're looking for a z-test, and it's called 2 samples or 2 sample for means. It's kind of weirdly worded, but it's going to be the last one that we're looking for there. Okay, then hit OK. And this window should pop up. Okay, so it says input, they want variable 1 range. Okay, well, variable 1 was method 1. Okay, so I'm going to click on this box right here, and I'm going to go highlight all the objects that I wanted to be identified as variable 1. That was my variable 1 data. And when I do that, you can see that it automatically fills that range with the appropriate notation to end up doing the calculations here in a moment. Okay. Then we want variable 2 range. So that's the second sample. So that was in column B. So I'll go highlight that stuff. And you can see that it automatically puts that column right here. Okay. The next thing you got to type in is the hypothesized mean difference. That's mu1 minus mu2. And we know that should be 0, right? So we're going to type 0 right there. All right. Now this next part, and I've got to do a little bit of maybe messing around with it to get this, but the next part, and mine's frozen. There you go. So the next part is asking us, what is the variance? It's for the first variable, it's that number right there. I don't know if there's a command. I don't know if I hit equals C2, if it will work with that. You might have to just type that number in. I'm going to try equals C2 and equals D2. Okay. I'm going to change my alpha. We want an alpha of 1%. And now where it says output range, okay, these are called radio buttons right here. You can click that one, okay? And it says your entry cannot be used, an integer or decimal number may be required. Okay, so what that's telling me right there is that, you see how I highlighted the C2? It's not going to let me reference a cell based on its value. I actually have to type that number in. So 0.000126585. And the other one is 0.000122911. Is that okay with everybody? Kind of a downfall, I think, of this. This thing does a lot of work for us. I think that's the one thing that can maybe be fixed. Alpha, like I said, is 0.01. Output range, if I click on that button and then click here, I just want to click somewhere in my Excel sheet. I'm not going to go somewhere crazy, but somewhere that does not overlap any of my current data. Okay, so I just want to go to a blank cell. Okay, because when we hit OK, this is going to populate a chart for us, and that's where it's going to put the chart. Okay, so I hit OK. You see that puts this chart together, right? Okay, so that chart, and I'm going to highlight these three, because it's basically already done, is highlight these three columns. I'm going to double click on one of those lines between the columns, and it'll just auto fit everything for me. Actually, I got to do it. Let's do it for this one as well. There we go. You can see now that it found the mean of both. Okay, it found the variance, or we typed the variance in for both of them. It counted how many observations that was, so it counted the sample size. Recorded the hypothesized mean that we typed that in. Okay. Standardized. Actually, that's the Z without standardizing. Okay. Gives me the probability of Z being less than or equal to Z of one tail. Gives me my critical values for a one tail and my critical value for a two tail. Does that make sense? Okay. Now these values are your p-values, and in this case, it's saying the p-values, I would argue that they're probably so small that Excel is just making them 0. Okay. But if I look at my critical values for a one tail, and we wanted a critical value for two tails, right? So we wanted those. Okay. I guess this is the Z-score. This is standardized. And that's why these numbers are so small. That number is huge. So we're on our normal curve, we're at 0. This would be all the way to the right at 64, okay, which is much larger than the Z critical values. So this would be in the rejection region. Does that make sense? Okay. I'll show you, and I had to process this data. I just grabbed this out of one of my textbooks. I'll do one. I'll generate one that gives us maybe some closer values with the Z and the Z critical values down here tomorrow. Maybe I'll see if I can like reverse engineer I don't know if I don't want to do 250 samples though, or values. We'll find one that will give us better data to analyze here. But basically what's going on here with this one is that if we're here at 0, our critical value here is at 2.57, and our other one is 2.57. This number here is our z-score, which is all the way out here at 64. That's in that critical region, right? Okay. Usually we don't see things that far off though, but it is what it is. Does that make sense? Okay. And that's what you've heard me talk, and let's see if I can show it to you. This is, IBM has a program called SPSS, which I don't know how to use much of it, really any of it. I've had to use it a couple times when I was in college, but it was just for like individual things. I never learned the structure of SPSS, but it's much like Excel. We can put in your data, okay? You see across the top, it's just called VAR. So each column is a variable. And then you've got options. You can do all the things that Excel does and more. Does that kind of make sense? But what it spits back to you eventually then is a table like this, okay? So if you're in a class that requires you to do research and you don't have a statistical background, what would happen is that you would be probably told to use SPSS, and they would probably give you some type of instruction on, okay, you have to decide what type of variables you have. Are they independent? What's your sample size? And decide, do I use a t-test? Do I use a z-test? Do I use a p-test? And they would show you then the process for getting that information input into SPSS, and it'll spit back a table that has your p-values, your critical values, and all that kind of stuff, and then that would allow you to make the decisions. Okay? When you go into courses like that are beyond elementary statistics, it is not necessarily, do I know the formulas? Can I utilize the formulas? It's, can I plug the data into something, let the computer analyze the data, process the data, and I then interpret the data. Does that make sense? Or interpret the results of that processed data. So I think we're going to, as we finish up the year here, use more of this type of stuff. Okay? I think that's going to be of benefit to you as you move on into other areas of schooling. Okay? So that's, we could do that. We could do the same thing. We could build our own. Okay, and we will build some of these on our own as we move forward. But that's all I've got for you. There is a 10.1 assignment open, not due tomorrow. We'll see some more examples of this tomorrow.